in the deep dark lair of the Batcave. Bruce, where are you, Bruce? Oh my god, Bruce. Is that necessary every single time?
Yes.
Oh god. Anyway, I was hoping Damien was his schoolwork. And we were wondering what you knew about Newton's first law.
I know everything about everything. I am Batman.
Good. Can you please explain it to him then? He's not getting it the way I'm explaining it.
Let me see how you do it.
Oh my god. Okay, see, Damien, Newton's first law says that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force.
Just like a low-life criminal, his head will remain on top of his shoulders unless my fist acts on it. And his brain isn't attached to his skull very well, so his head will move and his brain will not.
Or like a person inside of a car. The vessel and what's inside both have two different inertias and only one force acting on one object. And that's how we give people brain damage, Bruce.
He's fine.
No, he's not!
Speaking of inertia, a criminal's gun will only move out of his hand if the force of my battering acts on it.
And how does that even work, Bruce? According to the second law of motion, I don't see how that works.
And what's that?
F equals ma. Force equals mass times acceleration, Bruce.
I don't see the problem.
Okay, listen. What does one of those things even weigh? Bat computer. What's the weight of a battering?
0.2 kilograms.
And a gun?
A common weapon for street criminals is the Colt M1911. It weighs 39 ounces or 1.106 kilograms.
See, the mass is not massin', Bruce. Your batterings are too small to knock a gun anywhere, and we're not even considering a guy gripping that gun like his life depends on it. So, here's a better example, Damien. Damien, if the Batmobile weighs 3,175 kilograms-ish, how much force does it need to accelerate at 78 meters per second? 7.40 newtons? I have no idea. I must say that's about right. It's me, Batman.
No, Joker, no.
Yes, Batman. I've discovered the Batcave.
Stop it, Joker. We're having an important conversation.
Oh, yes, Batman. Newton's laws with Batbrain and the boy Blunder. I know a lot about that, too. I'm something of a Newton's law myself.
And what's that, Joker?
Tell me, Batman. According to Newton's third law, what happens when an unstoppable force meets an immovable object?
I don't know, Joker.
Exactly, Batman. You and I, we don't follow the rules. We don't follow society.
I don't even know what the third law is, Joker.
What? Newton's third law says that when one object exerts a force on another, the other exerts a force of equal magnitude but opposite direction.
No one asked you, Daddy Issues. Don't make me Jason Todd you.
Bro, chill.
Equal and opposite reactions, huh? Like this. Oh, why, Batman, why?
He was actually demonstrating force pairs. When your head slammed into the table exerted the same amount of force into your head, which is why it didn't simply break under your weight.
I didn't ask you, you orphan.
And this is why you leave clever wordplay to the Riddler. You know what, Batman? I know how we can end this once and for all.
Seriously, Joker, we're arm wrestling now?
Yes, Batman, this is my last resort. You see, Damien, even this is relevant to our discussion. At the moment, they are at a standstill, and this is because each arm is applying an equal amount of force in the opposite direction to each other. However, this doesn't always mean that these equal reactions cancel, because they happen literally all the time. Most of the time, both objects are able to move because each force is only acting on the other object. Like a ball bouncing. Both the ground and the ball exert an equal amount of force on each other, but only the force of the ball acts on the ground, and only the force of the ground acts on the ball. And according to Newton's second law, the ball is affected most by the same amount of force because its mass is less than the entire Earth. Are you okay, Batman?
Jean-Claude's driving me insane! Ah! For Gotham! And for science!